Hi, Miss Barber here. This is it. We have finally got to the lesson on the fundamental theorem of calculus. This very important theorem allows us to connect differential calculus and integral calculus. The learning objectives for this lesson are: demonstrate understanding of the fundamental theorem of calculus, often just truncated to FTC. Evaluate integrals using the fundamental theorem of calculus. Compute the average value of a function over an interval. And solve applications involving the definite integral and the FTC. We begin this lesson with the theorem. If a continuous function f has an antiderivative f over the closed interval a to b, then the integral from a to b of f of x dx is equal to f of b minus f of a. This is the fundamental theorem of calculus. Example 1. Evaluate the following integrals. A. The integral from 0 to 2 of x squared plus 1 dx. To do this definite integral, we first compute the indefinite integral. So the indefinite integral, or the antiderivative of x squared, is x to the add 1 to the power. So it would be cubed divided by 1 over the same power, so 1/3, plus the integral of 1 is x, and we evaluate from 0 to 2. So the algebra becomes, first we evaluate at 2, so 1/3, 2 cubed plus 2, we evaluate that, minus 1/3, 0 cubed, plus 0. Progressing, we'll have 1/3 times 2 cubed is 8 plus 2, and then minus, zeros are in all of the factors, so it'll just be 0. We get 8/3 plus 2, getting a common denominator to combine the terms. So let's see, we would have 6/3 for 2, which gives you 14/3. That is 4 2/3 when reduced, or in approximate form, you could write 4.66666666. Let's recall that when we did the Riemann sum with left end, the result was 3.74. With the right end, it was 5.75. With using the center rectangle, it was 4.625. When we increased the number of rectangles to 8, left-hand side was 4.1875, and the right hand for 8 rectangles was 5.1875. For this particular function, it appears that C sub 4, just 4 rectangles, but choosing the middle point, gave us closest to the actual answer. Evaluate the integral from -2 to +2 of 4 minus x squared dx. We begin this problem of solving the definite integral by computing the antiderivative. The antiderivative of 4 is 4x, and minus the antiderivative of x squared. You add 1 to the existing power, so it'll be x cubed, and then we divide by that same number, so it'd be 1/3. Let's evaluate this from -2 to +2. Let's first substitute. So I'll begin with 4 times 2 minus 1/3 2 cubed minus, then let's do this for the -2. So 4 times -2 minus 1/3 -2 cubed. 4 times 2 is 8. Then we would have 2 cubed, which is also 8, but divided by 3, minus, continuing, 4 times -2 is -8. Let's be careful with the number of negatives. -2 cubed retains the negative, but minus negative changes that to a positive, so positive 8/3. Let's proceed with the arithmetic. I have 8 minus -8, so that's 8 plus 8 or 16. Then I have minus 8/3 minus 8/3, which would be minus 16/3. In order to perform this arithmetic, I need a common denominator, so I'll multiply the first term, top and bottom, by 3, which will give me 48/3 minus 16/3, and we can simplify this to 32/3. Part C. Evaluate the integral from 0 to the natural log of 4, 2 times e to the x dx. Before we proceed with this, let's have a quick refresher on some exponential properties. And the one that I have in mind is if you have e to the ln of x, that is equal to x. That'll come in handy as we solve this problem. So in order to compute this definite integral, we compute the antiderivative. E to the x is nice because the antiderivative of e to the x is just e to the x, and we retain the constant of 2. Let's evaluate this from 0 to the natural log of 4. So we're going to put in those endpoint values every place we see an x. We begin with 2 e to the natural log of 4 minus 2 times e to the 0. Now the refresher comes in handy because e to the natural log of 4 is 4. So we'll have 2 times the natural log of 4 minus 2 times, and an exponent to a power of 0 is always just 1. So now we have 8 minus 2, and we know that this definite integral is equal to 6. Part D. Evaluate the integral from 0 to 4 of the quotient x divided by the quantity x squared plus 8 dx. This integral will require substitution. There are two standard ways in which definite integrals requiring substitution can be solved, but we begin them the same. So I'm going to begin with let, because we're doing substitution, u equal x squared plus 8. Then when you take the derivative, du, on the left-hand side, on the right-hand side, the derivative of x squared is 2x, and the derivative of 8 is 0, so we have 2x dx, and we're going to get x dx by itself. So I'll solve for 1/2 du equals x dx. Now we do have endpoints. Let's go ahead and replace all of them. So where we had 0, we'll get a new endpoint. U is equal to 0 squared plus 8, or 8. And for the other one, again, u is equal to x squared plus 8, so we'll replace it with 4. 4 squared plus 8, that's 16 plus 8, or 24. Now let's do our substitutions. What you have here is 0 to 4 of 1 over x squared plus 8 x dx. We'll do point by point replacements. So now where we had 0, we replace with 8, lower endpoint. Where we had 4, we replace with 24. Then 1 over where x squared plus 8 was, we substitute with u, and where x dx was, we replace with 1/2 du. Properties of integrals lets us take the constant to the outside of the integral, so 1/2 the integral from 8 to 24 of 1 over u du. The integral of 1 over u is a special integral. That's the natural log. So when you finish, you're going to have 1/2 the natural log of u, and we evaluate from 8 to 24. Let's substitute. This will give us 1/2 the natural log of 24 minus 1/2 the natural log of 8. This value is called the exact answer. Part E, evaluate the integral from 1 to 5 of the quantity x minus 1 divided by x dx. To do this integration or find the antiderivative, let's first do a term-by-term division. So we will write this integral in its equivalent form, the integral from 1 to 5 of x divided by x minus 1 divided by x dx. This can be simplified a little bit. X over x is just 1 minus, and then we still have 1 over x dx. Now we are ready to find the antiderivative. The antiderivative of 1 is just x. The antiderivative of 1 over x, that's a special one, and that is the natural log of x. And we compute this from 1 to 5. Let's proceed. That would be 5 minus the natural log of 5, and that quantity minus 1 minus the natural log of 1. Let's proceed. Not a whole lot we can do here. We got 5 minus ln of 5. And for the second set of terms, we've got 1 minus, and the natural log of 1 is just 0, so that doesn't matter. Let's combine like terms. 5 minus 1 is 4. 4 minus the natural log of 5. And this is your answer in exact form. Part F, integrate from 2 to 5 the quantity 1 over the square root of 6 minus t dt. This is another function that requires us to use the method of substitution. So let's begin with, let's let u equal the expression under the square root, which would be 6 minus t. Then the derivative on the left-hand side would be du, and on the right-hand side, the derivative would be minus dt. Remember, the derivative of 6 is 0, the derivative of t is 1, the negative stays put. Now, we don't have a negative anywhere there, so let's multiply by negative on both sides, and we get minus du equals dt. That lets us do a direct substitution. Now, let's get the new endpoints for this substitution. So for the 2, u at 2 is going to be the square root of 6 minus 2, square root of 4 is 2. And then for the 5, so we'll have the square root of 6 minus 5, the square root of 1 is just 1. Let's do all of the substitutions. So we will have the integral of, and where we had the 2, we will, strangely enough, it still stays 2. Where we had 5, though, the new value is 1. Then you have 1 over the square root of u. I'm going to just write it as to the 1/2. And then for the dt, we have to replace it with minus du. So we're going to use a couple of properties. We can bring the negative out front of the integral. So you have negative 2 to 1. Using exponent properties, u to the negative 1/2 du. Now, another definite integral property tells you can switch the endpoints, and that changes the sign. So let's just change this to 1 to 2 of u to the negative 1/2 du. Note, we use some neat properties here. Now we're ready to take the antiderivative. So the power is going to be u to the negative 1/2 plus 1 is positive 1/2, and it's still divided by 1/2. That is evaluated from 1 to 2. Let's do a little bit of arithmetic. 1 over 1/2 is just 2. That's nice. And instead of writing 1/2, I'll write square root from 1 to 2. Let's evaluate. That's 2 times the square root of 2 minus 2 times the square root of 1. So you get 2 times the square root of 2 minus 2. And again, this is an exact value answer. Northeast Airlines determines that the marginal profit resulting from the sale of the X seats on a plane traveling from Atlanta to Kansas City in hundreds of dollars is given by P prime of X equals the square root of X minus 6. Find the total profit when 140 seats are sold. To find the total profit, we must obtain the profit function, and that we know from the fundamental theorem of calculus is the integral of the derivative function p prime of x. That is, to get the profit function, we need to evaluate from 0 to 140, that's the 140 seats, and the p prime function, which would be x to the 1/2 minus 6 dx. Let's proceed. To get the integral of x to the 1/2, you add 1 to the power, so 1/2 plus 1 is 3/2, and the coefficient is 1 over that value when simplified will be 2/3 minus the antiderivative of 6 is 6x, and this expression needs to be evaluated from 0 to 140. So, let's put in the values. 2/3 times 140 to the power of 3/2 minus 6 times 140, and we need to subtract it evaluated at 0. So let's just go ahead and write 0. 2/3 times 0 to anything is 0, minus 6 times 0 is 0. Using your calculator, you get an approximate output, which looks like 264.33, again, minus 0. So we were told that this is in hundreds of dollars, so the answer would be expressed as either 264.33 hundredths, which is kind of awkward, so it would be more appropriate to move the decimal place over and say $26,433. What is displayed is a TI 84 Plus SE screen. When an exact answer is not needed, that is, an approximation is sufficient, we can compute numerical integration by using your TI 84. To do so, select Math, and then from that Math, select number 9. It looks like FNINT. It suggests integral. Let's put in our values. Lower endpoint is 0. Let's scroll up to the upper endpoint, which is 140. That's the number of seats. Let's scroll down and into the big bracket or the big parentheses, put in the function, which would be the square root of x, and then we also need to do minus 6, and let your calculator know that you're computing in terms of x. Now, when you click on enter, you get the output, which is 263.3348931. A company manufactures X smart TVs per month. The monthly marginal profit in dollars is given by P prime of X equals 300 minus 0.2x for X between 0 and 3,000 inclusive. The company is currently manufacturing 1,400 smart TVs per month, but is planning to increase production. Find the change in the monthly profit if monthly production is increased to 1,500 TVs. So in order to find the actual profit, we will need to integrate the marginal profit function. So P of X, and for the change we're looking for, we're going to start at 1,400 and increase to 1,500 TVs for the function 300 minus 0.2 x dx. Let's find the antiderivative. The antiderivative or integral of 300 is 300x. Then we will proceed. If you have x and you integrate, it increases by power of 1, so it becomes squared, and you divide by that same number. So the constant of 0.2 divided by 2 would give us 0.1, and we evaluate this function from 1400 to 1500. So let's proceed. We will have 300 times 1500 minus 0.1 times 1500 squared minus 300 times 1400 minus 0.1 times 1400 squared. Compute in your calculator, and the profit change is going to be $1,000. This tells us that profit increases by $1,000. Theorem. Let f be a continuous function over a closed interval, a to b. Its average value, usually denoted f subscript ave, over the closed interval a to b is given by f subscript ave equals 1 divided by the quantity b minus a times the integral from a to b of f of x dx. Let's practice using the average value theorem. Example, find the average value of g of t equals 6t squared minus 2t over the interval from -2 to 3. Let's go ahead and write the average value function theorem. So g ave is equal to 1 over b minus a times the integral from a to b of g of t dt. Let's put in our values. G ave of t, that's the average, it's going to be 1 divided by the quantity 3 minus -2, and the integral evaluated from -2 to 3 of the function 6t squared minus 2t dt. Let's proceed. 1 divided by 3 minus -2 is 5, and we want to integrate from -2 to 3 of 6t squared minus 2t dt. Let's do that. So now you will have the 1/5 of, and the integral of 6t squared. To integrate, the power increases by 1, so the 2 becomes a 3, and you also divide by that. So 6 divided by 3 gives you 2, minus the integral of t, increase the power by 1, makes it squared. You also divide by 2, so the existing constant of 2 divided by 2 just gives you the t squared, and we want to evaluate this from -2 to 3. Let's proceed. You will have 1/5 of, and then 2 times 3 cubed minus 3 squared minus 2 times -2 cubed minus -2 squared. Let's proceed. 1/5 times, and then 2 times 3 cubed minus 3 squared, you get 45 minus, then 2 times -3 cubed, then minus -2 squared will give you -20. With the arithmetic, we'll have 1/5 times 45 minus -20 is positive 65. And the final output is 13. The average value of g of t equals 6t squared minus 2t from -2 to 3 is 13. The temperature in degrees Fahrenheit in Minneapolis on a winter's day is modeled by the function f of x equals negative 0.12x cubed plus 0.38x squared minus 1.99x minus 10.1, where x is the number of hours after midnight and x is between 0 and 24. Find the average temperature in Minneapolis during this 24-hour period. So we are looking for the average function with respect to x. That would be 1 over upper bound 24 minus the lower bound 0, integrated from 0 to 24 of the function negative 0.01 x cubed plus 0.38 x squared minus 1.99x minus 10.1 dx. Continuing, we have 1 over 24. Let's use our TI-84 to compute this numerical integral. The screen displayed is a TI-84 plus CE. We want to perform numerical integration. To do so, hit the math key and then select 9, which says FN int, to suggest integration. Now the integration symbol pops up. For the lower bound on this integral, key in 0, and then for the upper bound, key in 24. Now where the function goes, carefully key in, use the negative symbol, not the minus, 0.012x, and then raise that to the power of 3. Continuing, plus 0.38x. We want to square that. Now subtract, so use the minus symbol, not the negative. 1.99x minus the constant 10.1, and then be sure to key in for the dx portion x. Now press enter, and the output we get is negative 59.808. Let's transfer that. Transferring, we will write negative 59.808. Multiply that with 1 over 24. And we get negative 2.492 degrees Fahrenheit. So a typical winter's day average temperature in Minneapolis is negative 2.5 degrees. Example, given the price-supply equation P of x equals 10 times e to the power of 0.05x, where P is the price in dollars and X is the supply of materials, find the average price over the supply interval from 20 to 30. We will use the average function theorem, and so we'd have P average with respect to X is equal to 1 divided by the difference of the endpoints, that's 30 minus 20, and we integrate from 20 to 30 of the price-supply equation, which is 10 e to the power of 0.05x dx. Continuing, 1 over 30 minus 20 is 10, and let's use our TI-84 to compute this numerical integral. To do numerical integration, use the math feature on your calculator, and from the Math Feature drop-down menu, pick number 9, which corresponds to numerical integration. When the integral symbol pops up, and the first blinking box, put in the lower bound for this problem, that'll be 20. Use the scroll to go up to the upper bound, key in 30. Now, to where the function goes, key in 10 times, then to get to e to the x, do second ln, and for the power, put in 0.05x. Now, scroll over to the D, and where it's blinking, select X to let the calculator know you want it integrated with respect to X. Press Enter. The output is 352.6814484. Let's transfer this to our workspace. Transferring the value from the calculator, we'll put in 352.6814484. Multiply that by 1/10, approximate it to the nearest cent, and that average price is $35.27.